Hi, I am doing FRQ number 7 for AP Chem, and the first question is, why does magnesium naturally form a 2+ cation instead of something else? So as you can see, I've written it out here. Mg normally has 2 valence electrons on its outer shell, and converting it into a 2+ takes out this outer shell and makes it have the desired 8 valence electrons. But I mean, if you were to ionize just 1, then it would still have 1 on the outer shell. So in making it a 2+ cation, it has the desired amount of valence electrons. All right, next question is, explain why MgCl can form 2 bonds and not 3. So if you look at the structure I wrote out here of Mg, so it has 2, like I said before, it has 2 valence electrons. And so in the instance of MgCl2, it works because it gives off a valence electron to each of them, and then each has 8 valence electrons. But with MgCl3, you can't do it because it's given off 2 of its valence electrons, and well, you can't create another one because then Mg would only have 7 on its outer shell, which you can't do. And then chlorine would have 8, but it doesn't work, is the main idea. All right, for the third question here, it's which element in the third row would take more energy than magnesium to have a second ionization. And so I said it was sodium, because not only do you go down to a smaller energy level, you are also taking away from the smaller energy level, which according to Coulomb's law needs a lot more energy, because when you go down to that second energy level and it's full of valence electrons, then it's smaller, and because there's more attraction to the nucleus. So then taking off that next electron will require a lot more energy. And the final question, number 4, is why does each ionization require more energy every time? So as you can see, I drew out a diagram for carbon. So with its starting, when it's normal, it has an even number of 6 protons and 6 electrons. So then the attraction is pretty normal, 1-to-1. But then when it's ionized for the first time, then it goes down to 6 and 5, meaning that each electron has more attraction to the nucleus, because the protons, there's still the same amount of protons, but there's a smaller amount of electrons. So then there's less energy to share between each electron, or less attraction to share between each electron, so each electron has more attraction, meaning that it's harder to ionize. And then when it goes down to the second ionization, it's 6-to-4, which creates even more shared attraction between each electron on the valence outer shell, and that means that it will take a lot more energy to ionize.